builds off of what we talked about yesterday. In our vocab notes in 4.1, we defined what a isosceles triangle is. And then in the practice for 4.2, the examples where we were working to find missing angles, I think there was one that was isosceles, but we want to make sure we understand all the details of isosceles triangles and are able to work with those and understand the markings and what they all mean when you're solving for missing pieces. Okay, so isosceles triangles, we said, have two sides that are congruent that are called the legs. Okay, and I think there was just an image of this in yesterday's notes. I don't know that everything was labeled though. Okay, so the two congruent sides are the legs. Okay, now it just says isosceles triangle have two sides called legs. I'm going to add above that, above where it says two sides, it's the two congruent sides. Okay, put that congruent symbol or write the word congruent. Okay, and then it has two congruent angles. Again, the angles are congruent as well, and they are called the base angles. Okay, these are down here in this picture. We mark sides congruent with tick marks, and we mark angles congruent with arcs. Okay, the legs are always directly across from the base angles. So I think I mentioned this yesterday, but the isosceles triangle is not always going to be drawn sitting on its base. Okay, so the legs are the congruent sides. I'm going to actually add that here. The third side which is the non-congruent side, is called the base. Okay, and that would be here, this is the base. Okay, it's the side that is not congruent. And then you'll notice up there in blue, this is the vertex angle. The vertex angle is where the legs meet. Okay, it is the non-congruent angle. And if we want to add that, we can add that as well. I think we'll have, there's a little bit of room right here. Okay, the angle, say the vertex angle where the legs meet. All right, so we feel good about the names of the parts. So two base angles and a vertex angle, two legs and a base for the sides. So sometimes you're given a picture and it's marked. So we can see Q and S are marked congruent. So these are the base angles, which means I know that there's two legs congruent, because if those two angles are congruent, there's two legs congruent. Which sides would be the legs? This one's drawn in the same direction as this example, so it should be pretty easy to tell. What would be the leg? One of the legs here. Y'all are eating into your work time by being silent. The side that's labeled 18, so side QR would be one of the legs. And what is the other leg? What side is that congruent to? But what's the name of the side?
Oh,
S is a point. Would be an angle. What's the side? The segment? RS. Good. So that means that would be 18 as well. And that's what they asked for. RS, segment RS is 18. Okay, so that one's pretty straightforward. You have two sides. You can find that if one of the sides that they give you is a leg, you obviously know the other leg is congruent. Now, if they gave you a leg and asked for the base, you would have to have more information. For instance, you would have to be told the perimeter or something that you could calculate what was left here, because there's not a set value that the side lengths have to add up to like there is for the angles. The angles always have to add to what? What do the angles of a triangle always add to? 180. So if it was base angles and vertex angle you were working with, you know the sum's always 180. But when we're talking side lengths, there's not a set sum that it always equals. All right, and number 2, we have the base angles. This one is drawn at a different direction. See how the base angles are not the two bottom angles? This triangle's like turned. That's fine. That means that my legs are not the left and right, but they are across from those base angles. So the 4x plus 5 is across from this angle, and across from the other base angle is the 6x minus 3. So those must be the two congruent sides. Those are the legs. And we said that the legs are congruent. They are equal to each other. So I'm going to write them equal to each other. If you need to separate your equation, the left and right side, draw that line down to separate. And then we need to move x's to one side, constants to the other. Looking at this, you could have written it the other way with the 6x minus 3 on the left. It doesn't matter. But I tend to move my smaller x value. Okay, so I'm going to move the 4x by subtraction because that leaves me with a positive x value. So that leaves me with 2x. Okay, and then you can do this in a separate step, or you can do this on the same line. It doesn't matter. Now I need to move my constants. So the 3 gets moved to the other side. So that leaves me with 8 for the constant. And then to get rid of the 2, I would divide. So I would end up with x equals 4. And then I go back and I double check what the question is asking. Because if they're asking for x, then fantastic, I'm done, which it is. Now you could check your work. If you plug this back in and confirm, those should come out equal. So if we plug 4 in for x on both of these, 4 times 4 is 16, plus 5 would be 21. And down here, 6 times 4 is 24, minus 3, that's also 21. So that checks out because they are supposed to be equal. All right, last but not least, now we're talking angle measures. This is what I was referring to a minute ago. I said, we know the 3 angles have to add to 180. So what we can do here, and actually we don't even need that because both of the angles that they give us are the base angles because they're across from those tick marks, right? Across from the tick marks are the base angles. So we know that these two angles are congruent. So we don't even need the triangle sum theorem here. We're just going to set the two angles congruent because congruent means equal measure. So same idea. And I come in here and I'm going to move my x's to one side. I'm going to move 5x so that's smaller and I want to deal with a positive x value. And then I'm going to move my constant to the left side. So I'm going to add 18 because that's the opposite of minus 18. So that gives me 21 equals 3x. And then I will divide out the 3 because that's the opposite. 3 times x, the opposite of times 3 is divided by 3. Again, if they ask for x, you're done, but they don't here. It says find the measure of angle O. So we always go back and reread our question. So I'm going to plug in, here's angle O. I'm going to plug in that x. and I'm going to calculate what that is. Okay, so 8 times 7 is 56 minus 18. This is 38. Now you could confirm that that works by plugging in a 7 to the other side. The 5 times 7 would be 35, plus 3 would be 38, and that should come out as the same. They both came out to 38, so that's correct. Okay, so it's similar to what we practiced yesterday, but this just uses isosceles triangles specifically. So you've got to know that the base angles are congruent, the legs are congruent, and you have to know which is which. You have to be able to identify those. We feel okay about isosceles triangles? Okay, so the delta math, I did link, I'm working on updating our calendar for Q2. So the delta math practice is linked here. And I might change the title of that. It is mostly 4.2, the notes that we took yesterday, but it has 4.3 mixed in there as well. So I'll change the title of that. But if you just click there, that'll take you to your assignment page and you can get started on the practice. What's up?